It's my pleasure to introduce our next esteemed speaker. Alex Izydorczyk is founder and CEO of Cybersyn, the data as a service company creating a real-time view into the world's economy. With nearly 7 years of experience leading the data science team at Coatue, a $70 billion investment manager, Alex brings a wealth of knowledge and expertise to the table. As the architect of Coatue's data science practice, he led a team of over 40 people in leveraging external data to drive investment decisions. Alex's background in private equity data infrastructure also includes an investment in Snowflake. His passion for real-time economic data led him to start Cybersyn in 2022. Please welcome Alex.
Thank you. Let me just start my timer here. Great. That said, just to give you some background on kind of who I am and what I've been up to, I spent about 6.5 years at Coatue, large hedge fund, focused on using real-time economic data. So think credit card data, clickstream data, point of sale data to model what the economy was doing. And we were traders effectively, right? So we were making investments in both public equity and private equity markets. The goal was very much to find data sets that could help us predict what the economy or what individual companies were going to do. So we were buying data from the likes of S&P and FactSet, but also buying data from what became known as alternative data vendors to the finance industry. So think everybody from the large players like Nielsen IQ, IQVIA, SNL, those types of firms, all the way down to small startups that just had unique data assets. In my time at Coatue, beyond just building a data science team, I also invested in companies. One of the companies I invested in was actually Domino way back in 2016. So I've had the distinct pleasure of speaking at almost every Rev. Let's hope this is not the last one. I don't like mess this up. And beyond Domino, also Snowflake. And Snowflake ended up funding Cybersyn, which is kind of what completes the arc. And Cybersyn is effectively a data as a service company focusing on proprietary data assets. But today I'm going to speak about something a little bit more boring than actually proprietary data assets. We'll get there, but we'll start with the boring. So I'll keep it a surprise, but let's start with a quote from Peter Thiel. So we were promised flying cars, and instead we got 140 characters, right? This typically is meant to kind of elicit the Silicon Valley jadedness that all the innovation has happened in the digital realm and not happened in sort of the physical realm. But I would argue in data management, sort of the opposite is true. That is, all the innovation is focused on like the flying cars of data science, like AI, and less so on some of the basics. And I hope to sort of convince you of that and show you perhaps or suggest a way out of that paradigm. So what do I mean by flying cars? So I think there's two types of flying cars. The first is AI, LLMs, machine learning, chatbots, what everybody's been talking about, right? These new AI models that instantly can build chat-like experiences with the data. Everybody promising that all of a sudden copilots for data will mean you won't need data scientists. Business users will just be able to ask questions of your data warehouse and so on, right? That's flying car number one. Flying car number two is proprietary data. Now, of course, my own company focuses on proprietary data, but I just want to point out here, right, there's been this craze that, hey, in order to differentiate in the world of AI, your proprietary data is everything. There's been these very large deals made, right, with the likes of Reddit and AP and series of other large publications, Shutterstock, et cetera, where these AI companies have paid millions of dollars for access to proprietary data, and that's meant to lead us to the promised land. These are great and very useful, but I would argue there's relatively simpler things that have not been solved that could be solved with some of the new technology, if given some thought. So let's talk about sort of the lack of a flying car in the first place. So let's say your sort of manager or somebody in the business says, hey, look, build a chat GPT experience, right? And have this GPT summarize all comments made by a public company CEO at earnings time. So let's look at the last 20 earnings transcripts that were released in the last 5 days. Let's summarize what those CEOs commented about inflation. Let's overlay that over companies that reported their sales numbers or retailers that reported that sales number. And let's maybe lay that over just the monthly advanced retail sales number from the US Census, right? See, the thing is, this is not really an AI problem. And what I mean it's not an AI problem is that it's trivial, right? Any open source AI tool can do this. The hard thing about any organization implementing or building such a tool would be actually access to that data, right? How many organizations have readily available access to even something as simple as public earnings transcripts, which are public, and have access to interest rates or consumer spending, which are census data points, right? I think most data science environments don't have easy access to this kind of external data. And I think a second example that illustrates this point further is, let's take another example. Let's say we want to answer the question of whether large increases in home price or large increases in volume of home sales have anything to do with the weather, right? Under the thesis that, hey, if there's maybe nicer weather, more people see more open houses. I don't know. It's a basic, trivial question. It could be an undergrad research project, right? And again, I think what's surprising is all of this data is public. You can actually get every mortgage deed granted in the United States is a public record and is freely available. So you can actually see the price of every home in the US and who the lender is if there was a first lien mortgage on it for free. And you can clearly compare that to localized weather data, which is also free from NOAA. But again, how many data science environments actually have this data available, right? No matter what industry you are, whether you're in finance and you're doing research for asset management, or whether you're in an operating industry or a real estate investor, right? These are pretty trivial data sets, but they're actually not trivial to have available in kind of a usable form. So my argument and kind of the theme of this speech is that the most proprietary data and AI are not actually the main issue, right? Before we can get flying cars, we sort of need to get the basics right? And just getting basic external data available, I think will push an organization a long way. Now, that's much easier said than done. I also think that even for firms using AI, external data becomes much, much more important, right? If you think about a large organization like OpenAI that trains GPT, the historical data they need to train on, so all the historical Reddit data or all the historical SEC filings, they effectively need that one time, right? The marginal value, the temporal value of the data of the update is pretty small. But if you want to build some sort of a chatbot on that helps with investment research, the relative importance at inference time of having data feeds to stock prices, to housing prices, to broad macro indicators, the structured data that is timely is actually very important to have that right. So borrowing from my key investor and key partner, Snowflake, Sridhar mentioned on a recent earnings call of all places, there's no AI strategy without a data strategy, and I fundamentally agree. So what makes free data hard, right? I like to say it's free as in freedom, not as in beer, right? And what I mean by this is that the data is ostensibly licensed for free. But in practice, right, even if you confine yourself to the limits of the US government and you just care about, let's even confine yourselves further, you just care about the consumer economy in the US and you just care about official agencies, there are still 30 plus economic agencies in the US that publish something to do with consumer spending, consumer credit, consumer net worth, and consumer dynamics, right? And I think the three key issues we identified are really ETL. So how do you find the right data? How do you even know it exists, where it is, who has it, and how do you load it into some centralized environment? 2, how do you parse it? Right? So it's often semi-structured, and I don't mean it's blobs of text. Of course, there's blobs of text, and AI can help with that. But even just the names of the variables of the time series are slightly different between different sources. And how do you resolve that? And that brings us to the last point, which is the join keys. So even just the way you refer to the states in the US or to CBSAs or MSAs can vary greatly across even the same agency's different survey products. So if you look at the BLS, they actually use 2 different encoding methods for geographies, right? So that's kind of like a further problem. So starting with ETL, the first question is how do you find the right data, right? These governments have made this data ostensibly public. Your tax dollars pay for it. But I guarantee you there are public data sets none of us have heard of that would actually be very useful in solving kind of a business problem. And I like to name a couple that I've just been surprised. So one I've already named is that every mortgage loan effectively is a public record. And if that mortgage loan is then securitized by Fannie or Freddie, that's also a public record. Every complaint consumers make to the CFPB about any bank or financial institution is a public record. That's kind of interesting. Every doctor, right? Every healthcare professional and every place of their practice and which licenses they hold in which state is a public record. Which means if you want to know how many chiropractors there are in this specific zip code, like that is all public free data, right? It's just that it's available on a myriad of different websites, all using different join keys, right? And so it's a little bit hard to find. And then once you find it, how do you keep it updated? So if you have a centralized environment, whether that's Domino or something else, how do you actually keep it updated and deal with the fact that these sources themselves change schemas all the time, right? Change documentation, change methodologies. They say they're going to release the data on this date, and then they don't, and they actually release it on a different date, or they do a partial release, right? One example I give here is that the Bureau of Labor Statistics has 15 different data releases this month, 15 different data product releases, and this is not counting the additional 15 releases they make, which are revisions of prior releases, and this is not counting their new and experimental products, and this is not counting their sunset deprecated products, right? So even keeping track with just the Bureau of Labor Statistics and all their data products is a lot. The second piece is about sort of parsing and structuring the sort of unstructured data. And again, I mean, certainly there's the concept of like, okay, I've got a bunch of text and I want to do sentiment analysis. But I would argue that's like the flying cars thing. Like, let's start simpler, right? So the simpler answer would be like, I just want to download all the 10Ks or 10Qs, all the quarterly reports, and I just want to pull out the section that lists management's discussion about risk factors. And in fact, it could be even more targeted than that. Every company, no matter what kind of public company you are mandated to have a section, and that section can be empty, called mining safety disclosures. Most companies don't have any mining safety disclosures, but many do, and those that do, it's always in one section. The problem is, these sections that come in HTML documents or raw text documents are fully sort of unstructured. So there's no XBRL tag, there's no good, consistent HTML DOM that you can parse to pull out that one section. There is no standardization. Every company can build their 10Q or K DOM however they like it. And that free text side, they don't actually have to tag with XBRL or anything else. And so this is why, if you actually want to buy this data, you have to go to S&P and pay them like $200,000 a year for this data, even though it's free, right? Other examples include government contracts. Every government contract, so anytime the government signs a contract with anybody, that's a public record. And if they ran an RFP, that's also a public record. But again, the actual description of what the RFP was for and sort of who bought it. So hey, I bought 10 Tableau licenses, obviously unstructured. Another great one would be bill of ladings. Import records are also free in public records. There's a few complications here. First, there's no centralized government website that has these. In some cases, you actually have to like contact the border agency, and then on top of that, the actual names of entities shipping things into the United States are a little bit of a mess, where Lululemon can be spelled 50 different ways, right? So how do you parse that? And then the last piece that I mentioned as a challenge is join keys, and this is related to parsing, but I think this is a little bit more about standards, right? Or rather the lack thereof. So in the early 2010s, the Securities Exchange Commission put out this concept of using XBRL in the Qs and Ks, at least for the GAAP financial kind of metrics, right? So the idea would be that every company, okay, fine, all their text disclosure would be unstructured, but their income statement, their balance sheet, like would be tagged so you could parse an individual number. And this was supposed to be revolutionary, right? And it never really worked. And the reason it never really worked is because XBRL, and you can think of XBRL as kind of like XML, right? It just became a sort of key value structure. The problem was the keys were never fully enforced. And so when you look at the XBRL, even though for any one company you can pull out a given number, there's like 20 different tags you can use to refer to revenue. And that's just revenue. So as soon as you get to debt instruments or debt covenants or executive compensation, like forget it, right? Every company can basically just make up their own tags. And so you get very little standardization. And then you've got other areas, I'm sure many in the room are familiar with the securities master problem that never ends, right? Where effectively, you know, with XBRL, the government sort of mandated something, and there's always a risk of regulatory capture, but at least there's, in theory, a central impartial body. With securities identifiers, of course, that's not the case at all. With securities identifiers, these are all proprietary for the most part, right? So CUSIP, FIGI, which is Bloomberg's, these are all proprietary identifiers. If you want to use them, you have to pay the owners, which naturally means that different firms will have different subscriptions that allow them to do different things. And there's a fair bit of regulatory capture here where you know, there's certain metrics like 13Fs, which are hedge fund holdings, that are published where the securities identifier is a CUSIP. And if you read the terms of service of that data, it says you actually have to pay FactSet a fee if you want to use the CUSIP, despite that the 13F is a government-mandated public disclosure form. So if that's not regulatory capture, I don't know what is. But nonetheless, there's no standard, and people have a hard time joining these things together, even if you are willing to pay every data provider or whatever fees they want. In other areas, though, there's very little at all. So for those who've worked with SKUs in retail CPG, there's no standardization at all. Every retailer makes up their own SKUs. Amazon has kind of moved towards a standardization they try to put on other people. But of course, who wants to adopt a different retailer's, a competitor's numbers? And then there is the GS1 effort, but again, there's just many formats of the GTINs, and many people internationally don't conform to this. And so this is a constant problem. Some central entity graph would be helpful. All right, so how do we make the car move faster, right? So okay, so the flying cars are nice, but they're not that helpful. We've got this small buggy. It's not really going anywhere. How do we make it move faster? How do we solve these like basic problems, right? And I would argue I have two suggestions that don't require the flying cars at all. So the first is around centralizing data assets, both technology-wise and data asset-wise. The second is around data marketplaces and data sharing. And then the third is actually using the flying cars on the road. And this is how some of these AI technologies could actually be used to solve some of these simpler problems. And no, it doesn't allow every business user to chat with your data and replace all your data scientists, but it could solve some of these perennial data quality issues that everybody has. So let's start with the first, centralizing data assets. So when I sort of raised the question, or the motivating problem here, I mentioned, does your organization have access to income levels by zip code, available, and whether, and have that joined together, and is that available to your data scientists? And I think that one step towards the answer to that being true is to centralize a little bit, right? And so that means you need first a centralized data platform. And I think that there's no one solution, right? I think one thing I really liked about Domino back at Co2 was that it at least created a replicable environment where different data scientists could have different environments that use the tools they wanted to use, but you could replicate the libraries and features that went into that environment, and you can point everybody to the same data assets, right? Other platforms, so Snowflake, which I'm using today, and Databricks is another example, although of course you should pick Snowflake. Right, the idea behind these data platforms is that they aim to centralize first and foremost the data. So everybody's accessing the data that's stored in one place. It doesn't need to be copied over, that saves costs, but it also means your governance model can apply regardless of how somebody hits that SQL warehouse, right? So there's a data platform angle to this, which is maturing. And then of course there's the data assets. And I think there's been a number of efforts here. So Data Commons, which is sponsored by Google, So fun fact, most people have not heard of data commons, but you know when you Google GDP of South Africa, and that like little modal comes up in Google search? So that is powered by data commons, right? And it's kind of a nonprofit project at Google that then gets integrated into the Google thing. And the idea is that the founder, Guha, basically is the founder of schema.org, and he's building an entity graph for these public domain data sets. I think it's a valiant attempt at joining these data sets. In certain other industries, right, so in economic data, we obviously have Fred, which has taken the industry hugely forward. It's not perfect. It doesn't have every source. The licensing is not perfect, but it's a step in the right direction. And then, of course, I would be sort of remiss if I didn't mention my own company, Cybersyn, where we're making efforts in this direction on Snowflake Marketplace. At some point, I'll plug myself more there. The second thing, and this is where I'm just explicitly going to plug Cybersyn, but really Snowflake is around marketplaces. And so what has basically happened is a lot of these large data platforms, Snowflake, but also Databricks, Google BigQuery, AWS, have kind of created these data marketplaces. And I think that data marketplaces are these perennial ideas that have never worked, right? So there's been hundreds of companies that have pitched me when I was at Cotu, oh, we have a data marketplace. And these things end up just being data catalogs. So they end up kind of being like the Craigslist for data vendors, right? And that doesn't solve, I mean, it's helpful, but it just doesn't solve much of a problem. It's like, okay, I'm going to code against your random API as opposed to like the vendor's API. But then at the end of the day, if I want to do a big contract with Bloomberg or FactSet, they're not going to make all the data available through your API. So I'm just going to end up writing custom code for FactSet and Bloomberg anyway, right? So it doesn't really solve much. I think what's different this time with Snowflake, Databricks, and BigQuery is that because these platforms are not independent data marketplaces, but they are sort of the data warehouse, the data platform you're centralizing your assets on, they do have this unique advantage where they're actually saving you any ETL work at all, right? So in the case of Snowflake or in the case of Databricks, the idea is that you simply click mount or sign up or copy for a data set. It appears as a database, and I'm using the Snowflake parlance. It appears as a database in your environment, and you can query that as if you had loaded it as a normal table into Snowflake, and the data vendor can simply continue to update that table, and you get those live updates as they happen. So if the data vendor does a schema migration, like that schema migration just automatically happens in your environment. And you can even get fancy features like versioning. So when Cybersyn publishes a table in Snowflake Marketplace, and then we end up changing that table, we have people who signed up for that table and started using it in their pipelines can continue to use the old version while we have a new version for new signups, right? And we can sort of maintain these multiple versions using the native application framework. And so I think that this is meaningfully different over the data marketplaces of yesterday that were just kind of the classifieds for data. And I think it's a big step forward. It also allows you to test more data vendors quickly, right? So you can simply say, okay, I want the trial data from these 5 vendors that all have the same thing, and I'm easily going to sort of compare them and see which one can actually join well against my data. And then the last piece, and I think this is really the most interesting piece, is where flying cars could actually be used on the road. So where could we basically borrow from these AI technologies and use them in their current state to solve some of these 3 problems I'd mentioned, right? And I think that there's a few areas where we have found as a data provider that I think apply to other data providers, but also to data consumers. And I don't think this is some crazy insight. I think other data providers also have this insight, and I think it's a question of execution. As an example, the CFO of FactSet was at I think Barclays conference a couple of weeks ago, and she mentioned FactSet has 12,000 employees. Of those 12,000 global employees, 6,000 are focused on data collection, right, and data curation. And so if you think about that in the world of LLMs, you can easily imagine how that number of people who are doing these kind of like relatively low value add per person tasks of cleaning or parsing data manually or checking data manually, these might be solved. And I want to go through some specific examples that we've done at Cybersyn or are planning on doing that I think the current technology can actually do quite well on. So the first is fuzzy joining. I think everybody who's worked in data extensively has at some point ran into this problem of fuzzy matching. And traditionally, this has been the realm of string distance, right? And everybody has their favorite string distance algorithm. Levenshtein distance, you could do versions of Euclidean distance. People have come up with creative things where you take a word and you convert it to sort of a phonetic representation, and then you match words that kind of like sound the same, right? And so there's been endless innovation here. And then of course you could build custom models to try to match things that are similar. But of course this is like time consuming, and it doesn't always solve the problem. So the example I like to give, so let's imagine we've got two sets of data. We've got some data from MasterCard and some data from a bank issuer. And you've got bill descriptors, which describe where the money was spent. And obviously you want to match between the two. How do you do it? So where string distance will fall down really quickly is in cases like Whole Foods. So imagine you've got Whole Foods, like the grocery store owned by Amazon. And then you've got Whole Foods LLC, which is spelled without a W. It's just some random, corner store, right? That just happens to be called Whole Foods LLC, right? So clearly those Whole Foods are extremely different. On the other hand, maybe sometimes when you shop at Whole Foods, because Amazon has introduced their quick checkout, it just shows up as actually an Amazon transaction. And so actually Amazon and Whole Foods with the W are similar, sort of. Whereas Whole Foods without the W is a completely different concept, right? No string distance can help you there because Amazon and Whole Foods are just completely different words. What can help you though is semantic context. Anybody with any domain expertise at all knows that Amazon famously bought Whole Foods and they're actually one company, and so they should be similar. So how do you do this with LLMs? Obviously the naive thing you could do is give two fields to an LLM and say, are these things the same, or do these belong to the same company? Obviously that's not practical because asking an LLM with today's technology, every pairwise comparison would be very expensive and very slow. But what you can do is you can embed both fields you want to join on. So in this case, embed both the description fields, right? And frankly, it's a little bit of a test and learn game of which embedding model should you use. But the conceptual idea is the embedding model should put these fields into a semantically similar space. And in that high dimensional embedding model, the idea would be that Amazon and Whole Foods with the W would be close in Euclidean or cosine distance than Whole Foods without the W, because that embedding model understands the concept of ownership, right? And this actually, in practice, works shockingly well with very little pre-training or very little specialization. This example in particular, we've done it. You can take an embedding model off the shelf, whether that's Snowflake's Arctic or OpenAI's ADA model or anything else, and it just kind of works out of the shelf. It's actually a little bit scary how well it works. So fuzzy joining. The second piece is structured data extraction. I think this one's pretty obvious, right? So it's clear hey, I've got a press release and I want to pull out this tabular data from this press release. I think that's pretty obvious. I think a lot of people have thought of this, and it does work well. I think what is maybe underappreciated is how well this can work if you fine-tune a relatively small model. So as it turns out, using GPT-4o or whatever on this kind of task where you've got a press release and you want tabular data, it works okay, but it's shockingly good. It makes for a cool vaporware demo in that you can get it to work perfectly if you prompt it correctly and so on. But in practice, these one-shot approaches are difficult to use if you actually want to use this in production and you want to parse hundreds of thousands of press releases and you want the error rate to be less than 1%. And so what works shockingly well in our experience has been taking very, very small models, very cheap models, the cheapest Llama 1 billion kind of thing, and fine-tuning them. And if you fine-tune them to exactly what you want, that can outperform even the largest cutting-edge LLMs. And I think what's great about that is that one, it's cheap, and two, it's pretty deterministic. And so what that means is effectively, you can actually put this into production after fine-tuning because it's very cheap to run, it's very fast, and you can basically use the same foundational model, so the same Llama 1 billion, and you can fine-tune them by just giving them, a couple hundred examples of what you want, it's pretty generic. It's not as if you're building like a custom machine learning model for this one task. So that has worked pretty well. And then the last piece is around labeling and classification. And I think this is, again, kind of obvious, but maybe underappreciated. So surprisingly, these LLMs do a really good job of standardizing taxonomies. So the things we often run into in our proprietary data, I mentioned we have a lot of consumer purchasing data, both SKU level and credit card data. And often what you do is you have these problems where you've got, like, say, a manufacturer or brand, and these are semantic problems, right? Like, what is a brand? Is Diet Coke a brand, or is Coke a brand, or what's a sub-brand? And how do you build that actual, like, taxonomy, right? And as it turns out, like, building a custom classifier for that problem, right, the way it would have been done in the past using a random forest or an SVM or something like that, it's just a lot of work. And you have to have positive examples of every case and negative examples of every case you may have encountered. I think what the LLMs can do that the custom models don't do as well is they can sort of extrapolate beyond the examples you give, right? So you give it a ton of examples of Coke, it comes across Pepsi, and Pepsi is a slightly different naming scheme, but the LLM's default choices about what to do with that Pepsi naming scheme like sort of make sense. And so it's relatively easy to get a working model that is at least as good as something that could be like sort of custom trained. Obviously the bar for error here is not perfection like in the fine-tuning case, but remember you're competing against the best alternative, which today is just not very good. All right, so takeaways. So I think that, if you remember nothing else, hopefully I got across 2 points, which is, does your organization have sort of basic external data in place? So if your data scientists or your analysts want to quickly compare their proprietary data or your company's proprietary data to demographics by zip code, like how easy is that, right? Is that a 2-3 hour project? Or is that something that needs to get scoped and ingested and you have to work with a vendor, right? Like there's a big difference, right? And I think that you could really accelerate the use cases of your data science team if this is easy to do and repeatable every time, right? And then the second piece, I hope I showed some just practical examples of where AI and LLMs, in their current state today can solve some of these key challenges that anybody who's done data munging has had. And no, these examples are not quite as appealing, maybe, as a chatbot that can let your CEO just ask questions of the data and give perfect answers every time. But these can actually really accelerate your data effort. And hopefully this is kind of like a little bit of a path for making the cars fly. With that, thank you. Please feel free to reach out to me, especially if you are thinking about public data sets or proprietary consumer spending data sets. We're obviously doing a lot of that at Cybersyn. I also write on Substack, magis.substack.com, around data markets and data as a service, so please check that out. And be sure to tell Nick that I should come back and continue my streak of speaking at Rev. I would appreciate that. All right, thank you. And yeah, maybe we do some questions or something.